We studied about the theorem of perpendicular axes. Now in theorem of perpendicular axes, we already explained the mathematical form of the theorem of perpendicular axes. Only statement is remain, and now I am again explaining this theorem of perpendicular axes. Now theorem of perpendicular, with the help of theorem of perpendicular axes, we can easily find the moment of inertia of laminar body. In this case, actually, there is a need of three mutually perpendicular axes. All these three axes are concurrent at a single point. Means these three axes are concurrent at point O. From that, two of them are in a plane of body, and another third axis is perpendicular to the plane of body or plane of object. तर थेरम ऑफ परपेंडिकुलर ॲक्सेस जो आहे याच्यामध्ये आपण जनरली थ्री ॲक्सेस असतात एकमेकांना म्युच्युअली परपेंडिकुलर आणि एकाच पॉइंट मधून जाणार त्यांना आपण काय म्हणतो कॉन्करंट असं म्हणतो. दिस थ्री ॲक्सेस आर कॉन्करंट ॲट पॉइंट ओ. ह्या पॉइंट ओ ला हे काय कॉन्करंट असेल. फ्रॉम दिस थ्री ॲक्सेस टू ऑफ देम आर इन दी प्लेन ऑफ ऑब्जेक्ट. दोन जे आहेत त्यातले ते कशात असतात त्या बॉडीच्या किंवा ऑब्जेक्टच्या प्लेन मध्येच असतात. अदर ॲक्सेस जो आहे तो काय असेल त्या दोन ॲक्सेसला परपेंडिकुलर किंवा बॉडीच्या प्लेनला किंवा ऑब्जेक्टच्या प्लेनला तो काय असेल परपेंडिकुलर असेल. असे लॅमिनर बॉडी असेल ना. इन केस ऑफ लॅमिनर बॉडी वी आर युजिंग दी theorem of perpendicular axes, and in case of any shape body we are applying the theorem of parallel axes. theorem of parallel axes जो आहे तो कोणत्याही टाइपच्या बॉडीला आपण अप्लाय करतो. पण स्पेशली लॅमिनर बॉडीज साठी कोणता थेरम अप्लाय करतो आपण theorem of perpendicular axes. Now there is a need of actually this theorem of perpendicular axes relates with the three mutually perpendicular axes, and these are concurrent at point. These are concurrent. हे तिन्ही जे आहेत ते काय असेल concurrent असेल, and these are related. This theorem relates with the three mutually perpendicular axes about which the moment of inertia we can find. The तीन concurrent axes असतात त्याच्या about जे आहेत मोमेंट ऑफ इनर्शिया आपण काय करू शकतो फाइंड आउट करू शकतो. नाउ लॅमिनर बॉडी मीन्स लीफ. वी नो फॉर एक्झाम्पल इज लीफ. नाउ लीफ इज लॅमिनर बॉडी मीन्स थिकनेस इज नेग्लिजिबल and this body is called as the laminar body. Also another symmetrical body such as ring, uniform disc, uniform ring, these also plane sheet, these are also the laminar body. तर प्लेन शीट झालं, रिंग झालं, तसंच थिन युनिफॉर्म डिस्क झाले, हे सगळे काय असतील आपल्याला लॅमिनर बॉडीज म्हणून कन्सिडर करतो. मग ह्या लॅमिनर बॉडीज मध्ये जे आहे आपल्याला थेरम ऑफ परपेंडिकुलर ॲक्सेस जो आहे तो कसा यूज करता येतो तो आपण find out करणार आहोत. Actually this theorem of perpendicular axes relates with the three mutually perpendicular axes about which this laminar body can rotate. त्यांच्या भोवताली ही बॉडी काय होते रोटेट होताना दिसते. Now figure shows the three mutually perpendicular axes. Now it consists the x and y. These are the two axes. These are perpendicular to each other and these are in the plane of object. These are in the plane of object. And third axis is z axis. It is perpendicular to the plane of object. Now these three axes, it consists the three axes, or figure consists the three axes. Now this laminar body is able to rotate about these three axes. ही लॅमिनर बॉडी अशी असते की ह्या तिन्ही ॲक्सिसच्या अबाउट काय होऊ शकते ती रोटेट होऊ शकते. नाउ इट कन्सिस्ट दिस फिगर कन्सिस्ट द थ्री ॲक्सेस. These three axes are mutually perpendicular to each other and it consists the rigid laminar body or rigid laminar object which can be rotated about these three axes. Now from that this x and y, these are in the plane of body, while y z axis is perpendicular to this plane of body. Now consider this small element of mass dm. Consider small element of mass dm. It is placed at point P. It is placed at point P. Now this distance, this OP is the distance from the perpendicular distance of the small element from the z axis. Now perpendiculars are drawn on x axis and y axis. Now PM is the perpendicular. PM is the perpendicular drawn on the x axis. Now this distance is equal to, actually that is the y intercept. That is the y intercept, and y intercept is denoted by the y. Therefore, this PM is equal to y. This is the perpendicular drawn on the x axis. Similarly, PN is perpendicular drawn on the y axis, and this PN is equal to x intercept. That is equal to OM. That is equal to x. This is equal to x. Now this small element. Now consider now these are the three axes. Suppose this is x axis, this is y axis, and this is z axis. X axis, y axis, and z axis. Now particle or object, small element is at this point, and these are the perpendiculars drawn on the x axis and y axis. X axis is towards this, while this is y axis. Now z axis is at this position. Now this distance, actually this distance, it is obtained by taking this right angle triangle. Now actually this is OMP and OLP, both are, these are the right angle triangles. And in this triangle, actually this is the right angle triangle. Now suppose OMP as well as ONP, these are the right angle triangle. By using this, we can find this OP. This OP is equal to what? By using the Pythagoras theorem, we get this as the OP square is equal to x square plus y square. This side is x and this is y. X square plus y square. But it is this OP is equal to, we get this as the square root of x square plus y square. X square plus y square. These are the perpendicular distances from x axis, y axis, and z axis. This is the perpendicular distance from x axis. हे distance जे आहे काय झाले ह्या dm चं perpendicular distance from x axis किती असेल y. परत इथे dm small element perpendicular distance from y axis काय असेल x, and perpendicular distance from z axis OP is equal to काय असेल square root of x square plus y square. Now these are the perpendicular distances from the x axis, y axis, and z axis. Now from this we can find the moment of inertia about x axis, y axis, and z axis. Now this moment of inertia about x axis. Moment of inertia about x axis. Now concentrate on this axis. Now this particle or this small element is rotating about this axis. This is at distance y from the x axis. Therefore, we get this as the integration of this small element is it is equal to y square into d. Y square, dm is mass of this object, small element, and this small element rotates about this axis, and this distance is y. Therefore, it is equal to y square dm. This is the moment of inertia of small element, and moment of inertia of this body about the x-axis, it is equal to integration of y square dm. Similarly, moment of inertia about y-axis, on this small element. Now consider this is the axis, and now it is rotating. This small element is rotating about this axis as like this, but this is at distance x from the y-axis. Therefore, we get this as the x square into d. We know mass into square of the distance from the axis of rotation. It is called as the integration. Now, this is the integration. This is the moment of inertia of this small element and moment of inertia of total body is obtained by taking the integration. Now these are the moment of inertia about x-axis and about y-axis. Now moment of inertia about z-axis. Now the small element is at distance this from the axis of rotation. Therefore, we get this moment of inertia about z-axis. It is equal to x square. It is equal to square root of x square plus y square. Square of this into dm. Into dm. This is the moment of inertia about the z-axis, but it is equal to, we can write this as the x square plus y square into dm. And this is the moment of inertia of small element. While moment of inertia of total body, it is equal to integration of x square plus y square dm. Now by separating this one, by multiplying with this to this x square and y square, we get this as the x square dm plus, we can write this as the y square dm. Now the left side is iz, but this integration of x square dm, it is equal to iy, while integration of y square dm, it is equal to ix. Therefore we get this as the iz is equal to iy plus ix. We can write this as the iz is equal to ix plus iy, and this is the mathematical form of the theorem of perpendicular axis. This is the mathematical form of the theorem of perpendicular axis. And from this we can state that moment of inertia of a laminar body, moment of inertia of a laminar body about the axis perpendicular to its plane, it is equal to sum of moment of inertia of the body about two mutually perpendicular axes, in its plane, and all these three axes being concurrent, and this is the statement of theorem of perpendicular axis. Theorem of perpendicular axis चा statement काय म्हटले थे? Moment of inertia about the axis, moment of inertia of plane lamina or laminar body, moment of inertia of laminar body about the axis perpendicular to its plane, it is equal to sum of its moment of inertia about two mutually perpendicular axes, in its plane, all these axes concurrent, all these axes being concurrent. हे सगळे axes जे आहेत ते काय असतील, concurrent असतील. अशा वेळेस याच्या अबाउट मोमेंट ऑफ इनर्शिया जो आहे तो कशाच्या, या दोन ॲक्सेसच्या अबाउट मोमेंट ऑफ इनर्शिया आहे त्यांच्या बेरजे एवढा असतो. अँड दिस इज द थिअरम ऑफ परपेंडिक्युलर ॲक्सेस. नाउ नेक्स्ट पॉइंट इज थिअरम ऑफ परपेंडिक्युलर ॲक्सेस. We are going to study about the angular momentum. Angular momentum. Angular momentum. Or it is also called as a moment of linear momentum. Moment of linear momentum. The angular momentum, this quantity is related with the rotational dynamics, especially when there is a circular motion or rotational motion. At that time we are studying the quantity that is called as the angular momentum. Before in linear linear motion or translational motion, we studied about the linear momentum. Now moment of linear momentum is called as the angular momentum. Moment of linear momentum is called as the angular momentum. Actually, when we are comparing this quantity, we know this force is analogous to the torque. Similarly, this linear momentum is also analogous to the angular momentum in rotational motion. तर हे analogous quantity जे आहेत linear momentum कशाशी analogous आहे angular momentum. परंतु linear momentum पासून आपल्याला काय फाइंड आउट करता येतं angular momentum फाइंड आउट करता येतं. Suppose body is performing the circular motion or rotational motion. Body जे आहे ते काय परफॉर्म करते circular motion परफॉर्म करते. At that time this body is moving with a tangential velocity v. And due to this tangential velocity, this body possesses the mass, and product of this mass and velocity it is called as the linear momentum. Product of this mass and velocity it is called as the linear momentum. Now we know linear momentum is equal to P is equal to mv. P जो आहे तो काय आपल्याला पाहायला मिळेल mv or P bar is equal to m into v bar in vector form. And from this we want to find the angular momentum. Angular momentum is moment of linear momentum. We know torque is equal to moment of force. We are writing this as the 2 bar is equal to r bar cross f bar. Moment of force. Actually, in this case, we are finding this is the force. Same force is acting at two ends. Now this moment arm is taken as the r. Moment arm is taken as the r. A moment arm into the force. It is called as the moment of force. A moment of force which is called as the torque. By comparing this, we can write the linear momentum, angular momentum. It is the moment of linear momentum. Therefore, we can write this as the r bar cross p bar, in which r bar is the moment arm while p bar is the momentum. P bar is the momentum. Instead of this there is a p bar, and this is the momentum. Now in this case we get this angular momentum, it is equal to r bar cross p. This angular momentum is always along the axis. च्या along angular momentum आपल्याला पाहायला मिळेल. Now this L bar is equal to R bar cross P bar. This is the moment of linear movement. पहा इथे टॉर्क काय लिहितो आपण moment of force. Moment of force म्हणजे काय moment R multiply by force असं लिहितो. Moment of force याच्याऐवजी इथे linear momentum च्या ऐवजी force आहे म्हणून R bar cross काय घेतो F. आणि मग इथे जे आहे moment of linear momentum म्हणजेच काय ना R bar cross P bar. R bar cross P bar. Now this angle, this is the small angle between the R and P. This angle is always 90 degree. We can write the magnitude L is equal to RP sin theta. But the angle is 90 degree. Therefore, we get this as the RP sin 90. But sin 90 is equal to always 1. Therefore, L is equal to RP, or we can write this L is equal to PR. This is the magnitude of the angle. Now this is the angular momentum. Now in case of angular momentum, this is the product of moment arm and the linear momentum. Moment arm and linear momentum. This product is called as the angular momentum. तर angular momentum जो आहे तो काय असेल moment arm आणि linear momentum या दोन्हीच्या प्रॉडक्टला आपण काय म्हणतो angular momentum असं म्हणतो. मग याच्यावरून आपण एक्सप्रेशन फॉर angular momentum. एक्सप्रेशन फॉर angular momentum. angular momentum साठी एक्सप्रेशन जे आहे ते काय आपल्याला येतं ते आपण फाइंड आउट करणार आहोत. Expression for angular momentum in terms of in terms of moment of inertia. In terms of moment of inertia. Expression for angular momentum in terms of moment of inertia. त्यासाठी परत डायग्राम जे आहे तुम्ही आहे तसेच काढले तरी चालेल. एक्सप्रेशन फॉर द अँग्युलर मोमेंटम. अँग्युलर मोमेंटम साठी आपल्याला एक्सप्रेशन फाइंड आउट करायचं आहे. कंपेअर केलं आपण तर लिनियर मोमेंटम आणि अँग्युलर मोमेंटम त्याच्यावरून सहजपणे आपल्याला याच्यासाठी इक्वेशन जे आहे ते काय येईल ते आपल्याला फाइंड आउट करता येईल. बिफोर दॅट वी नो दिस अँग्युलर मोमेंटम इज द मोमेंट ऑफ लिनियर मोमेंटम. अँग्युलर मोमेंटम म्हणजे मोमेंट ऑफ लिनियर मोमेंटम आहे, त्याच्यावरून आपण हे फाइंड आउट करावं. इथे आता व्हेलॉसिटी घेतलं तरी चालेल किंवा P1 P2 Pn P2 असे घेतले तरी चालतील आणि याच्यावरून आपण फाइंड आउट करतो R आणि P याच्यावरून आपल्याला रिलेशन मिळतो. V1 V2 Vn आणि V2 अशा पद्धतीने लिहिले तरी चालू शकते. कोणत्याही पद्धतीने असू द्या. इन दिस केस इट रोटेट्स विथ द ओमेगा, कॉन्स्टंट अँग्युलर व्हेलॉसिटी ओमेगा. नाउ we want to find the expression for the angular momentum in terms of moment of inertia. We know in linear motion, linear momentum P is equal to mv. P is equal to mv अशा पद्धतीने रिलेशन माहिती आहे. तर त्याच्यावरूनच आपल्याला इथे हे जे आहे अँग्युलर मोमेंटम जो आहे तो काय मिळेल तुम्हाला. याच्याशी एनालॉगस क्वांटिटी जर घेतलं, दिस मास इज एनालॉगस टू द मोमेंट ऑफ इनर्शिया while this v is analogous to the angular velocity. From that we get relation as L is equal to I omega. तर हे रिलेशन आपल्याला काय करायचं आहे, फाइंड आउट करायचं. L चं जे आहे L चं रिलेशन जे आहे ते आपल्याला फाइंड आउट करायचं आहे. नाउ परत स्टार्ट करूया. काय म्हणणार, फिगर शोज द रिजिड body rotating with a constant angular velocity. This figure shows the rigid object. It is rotating with the constant angular velocity. Now, for a simple calculation of for a simple transformation, consider it consists the n number of particles. It consists the n number of particles. Let m1, let m1, let m1, m2, let m1. Let m1, m2 and mn. Let m1, m2, dash mn with the masses of these particles. It consists the n number of particles. M1, m2, dash mn with the masses of these particles, and these are situated at perpendicular distances r1, r2, dash rn from the axis of rotation. These are situated at distances r1, r2, dash rn from the axis of rotation. Now, when this body rotates with the constant angular velocity omega, all particles rotates with the constant angular velocity omega. In other words, we can say that the angular velocity of all the particles is same, but their linear velocities are different because these are at different distances from the axis of rotation. हे वेगवेगळ्या डिस्टन्सला काय ॲक्सिस ऑफ रोटेशन पासून आहे म्हणून त्यांच्या लिनियर व्हेलॉसिटीज काय असतील डिफरंट असतील. ऑल द पार्टिकल्स rotates with the or perform the circular motions about the axis of rotation with the constant angular velocity, but their linear velocities are different. And we know v is equal to r omega. This is the relation between the linear velocity and angular velocity. Therefore, we can find the moment of inertia of this relation between linear velocity and angular velocity of first particle. It is equal to v1 is equal to velocity of first particle is v1 is equal to r1 omega, because omega is same for all particles. Similarly, v2 is equal to r2 omega, and that vn is equal to rn omega. At first we are finding the all quantities related with the first particle. Now linear momentum of first particle, it is equal to p1 bar. P1 bar, it is equal to mass into mass of first particle is m1, while it is equal to mass into velocity, it is equal to m1 v1. But v1 is equal to r1 omega. v1 is equal to what? r1 omega. Therefore we get this as the m1 r1 omega. Now this is the linear momentum of first particle. Now angular momentum of first particle, this angular momentum of first particle L1 bar, it is equal to what? R1 bar cross P1 bar, but it is equal to R1 P1, because the magnitude of this L1 bar, we can write this L1 bar. From this we can write the L1. And now this L1 bar is R1 cross P1 bar, but L1 is equal to what? RP, sin theta, but angle between R and P is always 90 degree. Therefore it is equal to RP. Now in case of first particle, it is R1 into P1. Now by substituting value of P1 as M1 R1 omega in this equation, we get this as the R1 into M1 R1 omega, which is equal to M1 R1 square into omega. M1 R1 into R1, it is R1 square, M1 R1 square omega. Thus, this is the angular momentum of first particle. Similarly, we can write the L2 angular momentum of second particle. It is equal to M2 R2 square omega. M2 R2 square omega. And Ln is the angular momentum of nth particle. Its mass is mn. We get this as the mn into Rn square into omega. And all these moment of inertia are along the axis of rotation. These are along the axis of rotation. Now all these are in one direction when orientation is same, or when this rotation is in one plane. All these angular momentums are in upward direction. Therefore total angular momentum of this body, it is equal to sum of all these angular momentums, or all these are in the same direction. That's why all these angular momentums are added, and it gives the resultant angular momentum. Therefore resultant angular momentum of this body, L is equal to L1 plus L2 plus Ln. L1 plus L2 plus Ln. We are considering the angular magnitudes of this angular momentum. Now we get this L is equal to, it is equal to M1 R1 square omega plus M2 R2 square omega plus Mn Rn square into. By taking the common, this M1 R1 square plus M2, we can write this as the M1 R1 square plus M2 R2 square plus m n r n square, and common term is taken outside of this bracket, that is omega. But it is equal to, we can write in the form of summation. It is equal to summation of m r I square, I runs from 1 to n into omega, but this value is the moment of inertia. Since we know this is equal to, we know this summation of I runs from 1 to n mi ri square, it is equal to moment of inertia. From this we get this as L is equal to I omega. L is equal to I omega, and this is the angular momentum in terms of moment of inertia. This is the angular momentum in terms of moment of inertia. तर हे जे आहे काय असेल angular momentum in terms of moment of inertia आहे. आलं लक्षात. Now also we know in linear motion p is equal to mv, and from this we can say that this linear momentum or angular momentum is analogous to the linear momentum in translational motion if I replaces the m, and this is the physical significance of this linear momentum. तर थोडक्यात जर समजा I ने m रिप्लेस केला तर काय होतं ही अँग्युलर मोमेंटम कशाशी अनालॉगस असेल लिनियर मोमेंटम, आणि हाच काय असेल याचा फिजिकल सिग्निफिकन्स असेल. म्हणजे थोडक्यात आपण वरवर ऑब्झर्व केलं असता काय दिसतं I आणि m I ने m रिप्लेस केला तर अँग्युलर मोमेंटम आणि लिनियर मोमेंटम काय असतील अनालॉगस असतील. दिस अँग्युलर मोमेंटम इज अनालॉगस टू द लिनियर मोमेंटम इफ I replaces the m, and this is the physical significance of this linear momentum. किंवा हाच काय असेल फिजिकल सिग्निफिकन्स असेल. Now similarly we want to find the torque expression of torque in terms of moment of inertia. Angular momentum च्या ऐवजी काय असेल expression for torque, torque जो आहे expression for torque in terms of moment of inertia. Expression for torque इथे लिहूया आपण expression for torque. Expression for torque in terms of moment of inertia. पुन्हा सेम डायग्राम असेल, अशाच पद्धतीने डायग्राम काढले, फक्त इथे P1 बार P2 बार आणि Pn बार च्या ऐवजी काय असेल इथे F1 बार Fn बार आणि F2 बार अशा पद्धतीने. त्यानंतर now we want to find the expression for the torque. टॉर्क साठी आपल्याला एक्सप्रेशन फाइंड आउट करायचं आहे. तर एक्सप्रेशन फाइंड आउट करताना इथे आपण पाहिलं मोमेंटमच्या ऐवजी काय असेल इथे फोर्स असेल. नाउ टॉर्क इज एनालॉगस टू द फोर्स इन लिनियर मोशन मध्ये फोर्स असतो त्याच्याशी एनालॉगस काय असेल टॉर्क व्हिच इज इन अ रोटेशनल मोशन. these are analogous means these are similar functioning quantities. दोन्ही कसे आहेत ह्या सिमिलर फंक्शनिंग क्वांटिटीज आहेत ते आपण फाइंड आउट करणार आहोत. एक्सप्रेशन फॉर द टॉर्क इन टर्म्स ऑफ द मोमेंट ऑफ इनर्शिया. फिगर shows the rigid body or rigid object. It is rotating about the axis of rotation and it is rotating with the constant angular acceleration alpha. इथे angular velocity च्या ऐवजी फक्त काय असेल constant angular acceleration alpha. Now for the simplification consider it consists the n number of particles. Now m1 m2 dash mn, these are the masses of these particles. These are situated at perpendicular distances r1 r2 dash rn from the axis of rotation. Now when it rotates, all the particles perform the circular motion with constant angular acceleration. Means all particles having a constant angular acceleration, but their linear accelerations are different. इथे linear velocities होते त्याच्याऐवजी ते काय असेल, but their linear accelerations are different. Linear accelerations are different because linear acceleration depend on this distance from the axis of rotation, because it depends upon the r. That's why these linear accelerations are different and angular accelerations of these particles are same. We know relation between the linear acceleration, that is the a is equal to r alpha. This is the relation between linear acceleration and angular acceleration. Alpha is the angular acceleration, while this is the linear acceleration. Therefore, linear acceleration of first particle is a1 is equal to r1 alpha. A1 is equal to r1 alpha. Alpha is same for all particles, but a1 is different for different particles. Now in this case we get this as the a2 is equal to r2 alpha. A2 is equal to r2 alpha. Similarly, an, this is the acceleration of nth particle, it is equal to rn alpha. Now this is the linear accelerations of this particle. ह्या acceleration जे आहे ह्या particles चे आपल्याला फाइंड आउट अशा पद्धतीने आपण फाइंड आउट करतो. But we know we want force when there is an acceleration. Actually this particle provides the force. Therefore force of first particle, force of first particle काय आहे, F1 bar is equal to F1 bar force जो आहे काय असेल, mass into acceleration. म्हणजे आपण इथे काय लिहू शकतो ते F1 जो आहे मॅग्निट्यूड मध्ये कन्सिडर केलं तर काय आहे, m1 into acceleration. m1 into a1, that is the acceleration. m1 into काय आहे ते अल्फा. दिस इज द m1 r1 alpha. m1 r1 alpha इथे सबस्टिट्यूट केलं तर काय आहे, m1 r1 alpha. This is the force acting on the particle of mass m1. Similarly, we can find the forces acting on the different particles. Now we want to find the torque acting on this particle. Now torque is the 2 bar is equal to r bar cross f bar. Torque acting on the first particle, magnitude काय आहे इथे r into f. r आणि f मध्ये अँगल काय असेल इथे 90 डिग्री आहे, बरोबर. इथे r आणि f मध्ये काय इथे 90 डिग्री आहे. म्हटलं हे काय आहे, मॅग्निट्यूड मध्ये τ is equal to rf. τ is equal to r into f. But τ1 is equal to r1 into f1. τ1 is equal to r1 into f1, but f1 is equal to m1 r1 alpha. It is equal to we can write this as the r1 into m1 r1 alpha. This time it is equal to m1 r1 square into alpha. This is the torque acting on the first particle. Similarly, we can find the torque acting on the second particle. T2 is equal to m2 r2 square into alpha. And thus we get τn is equal to mn rn square into alpha. All these are the torques. Now these torques are always acting on the about the axis of rotation. These torques are always along the axis of rotation, and this torque actually when we are restricted this motion in one plane, all these are in one direction. Therefore total torque is also sum of the all torques. सगळ्या torques चे sum म्हणजेच काय असेल, total torque acting on this body. Therefore we get this torque is equal to काय लिहिणार इथे आपण, torque is equal to is equal to total torque, that is equal to is equal to τ1 plus τ2 plus τn. But torque it is equal to m1 r1 square alpha plus m2 r2 square alpha plus mn rn square alpha. But alpha is common in all this term. Therefore we get this as the m1 r1 square plus m2 r2 square plus mrn square into alpha. But this is the moment of inertia. We can write this as the summation of mi ri square. I runs from 1 to n into alpha. Therefore, this 2 is equal to I into alpha. 2 is equal to I into alpha. See this summation of moment of inertia. Summation of mi ri square. I runs from 1 to n. It is equal to moment of inertia, and this is the torque in terms of expression for the torque in terms of moment of inertia. टॉर्क साठी मोमेंट ऑफ इनर्शिया जो आहे तो अशा पद्धतीने आपल्याला पाहायला मिळेल. टो इज इक्वल टू आय इंटू अल्फा, अँड दिस इज द एक्सप्रेशन फॉर टॉर्क इन टर्म्स ऑफ मोमेंट ऑफ इनर्शिया. मोमेंट ऑफ इनर्शिया साठी एक्सप्रेशन जे आहे इन टर्म्स ऑफ टॉर्क साठी एक्सप्रेशन जे आहे इन टर्म्स ऑफ मोमेंट ऑफ इनर्शिया तुम्हाला अशा पद्धतीने मिळेल. टो इज इक्वल टू आय अल्फा, अँड इन लिनियर मोशन वी नो फोर्स इज इक्वल टू mass into acceleration. Now this torque is analogous to the force. This torque is analogous to the linear force in linear motion if I replaces the mass, and this is the physical significance of this moment torque. Now we studied in this lecture two expression for the angular momentum and expression for the torque. Now I am stopping at this moment. Tomorrow we will discuss the next point.